The Ever Given. How did it happen? By now you must know exactly what happened, right? Wrong! Hello everybody! I am Nick the Naval Architect. Like everybody else, I watched the story of the Ever Given, and I formed my own theories about what had happened. I took one glance at the incident, and immediately I developed a rock-solid theory about what they did wrong. Judgment all over the place. Except I was wrong. As the events unfolded, new information came out, and I learned the increasing complexity of the accident. Each time, I adjusted my viewpoint. I developed a new theory, which failed once again as new information came out. Over a year later, and I still cannot definitively identify the chain of events that created that accident. I just don't know. Science starts by admitting our ignorance and asking questions. Vessels like the Ever Given lead the cutting edge of ship science. From a scientific standpoint, accidents with these vessels may point to some new piece of physics that we never noticed before, something else that we need to account for. And that also has a major implication for safety. Every ship in the world benefits if we can understand what happened to the Ever Given. We need to learn from our mistakes or else we risk repeating them. So today, I'm going to review all of the facts that I could find from the Ever Given incident and discuss what are the likely causes of this incident based on the things that I could actually confirm. So why am I 1 year late? It would have been great to jump on the wave of Ever Given videos that came out a year ago. Because engineering is not about publicity. We don't jump to conclusions just to get on some YouTube hit lists. We wait for the facts. We form our own conclusions carefully after reviewing all of the evidence. I've done this type of engineering before for forensic analysis, and it's very important to look at the entire accident and look at all the details, because the simplest key detail from somebody's report or description of what happened can drastically alter the implications for the whole physics and engineering scenario. So why am I a year late? Well, I was waiting and hoping for an accident investigation report to come out. Unfortunately, there is no public report. The lawsuit between the owners of the Ever Given and the Suez Canal Authority, that was settled privately. We don't have legal rights to know exactly what happened in that lawsuit, or the findings from that investigation. And this isn't a coincidence. A lot of the reason that we're seeing privacy from all of these parties is because they received huge scrutiny and speculation from the entire world when this happened. That can have real economic damage for the owners and the Suez Canal. So of course they're hesitant to share any information. Of course they don't want to provide details that would allow more lawyers to sue them. That's why today I'm going to be very careful to keep everything about facts and real conclusions, not wild speculation. So the first thing we can definitively say is that the vessel had some problem with their steering, based on the simple fact that they didn't go where they wanted to. Now, when I first saw that vessel track, I thought there might be something wrong with the actual control mechanism for the steering. That rudder is controlled by a hydraulic steering gear, and a fault in that system could cause the rudder to oversteer, going past the specified rudder angle each time. Now, this type of fault would create that hunting pattern that we saw in the vessel track, where the ship is struggling to hold a straight line, and it keeps veering left and right of its course. But I didn't find any reports of problems with the steering gear. All the information that I could find indicated that the vessel was mechanically fit and working just fine. Okay, if the problem isn't with the steering gear, maybe the rudder was simply undersized. We all remember the story about the Titanic. Too small of a rudder meant that they could not churn fast enough and they hit the iceberg. But too small of a rudder also means that you can't stop your churn fast enough. A ship the size of the Ever Given, she has a lot of momentum when she starts to churn, and that requires a very large rudder to stop the churn. too little control from the rudder, and we can see that pattern of overshooting the turns. We do have a standard maneuvering test to check for this exact type of problem. It's called a zigzag test. The zigzag test is something that would have been done as a full-scale trial performed on the ship after they finished construction. There are a whole series of sea trials to confirm performance. And among other things, this zigzag test measures the response time for the rudder to stop a churn. They put the rudder hard over to one side, wait a specified time interval, recording how the ship churns, and then immediately turn the rudder hard over to the other side. And we're actually measuring how long it takes for the ship to stop its churn and start going the other way. International standards include requirements for that response time. There are minimum values that they should have to meet. Did the Ever Given fail to meet those standards? I don't know. Those shipyard trials would have been private information for the owner specifically. I will say that I doubt the vessel owners would accept a vessel without first testing its functionality. Sea trials are standard practice before accepting a vessel from the shipyard. Now we come to the issue of the wind. The popular theory is that the wind pushed sideways and blew the vessel off of its track. Weather stations did record wind speeds of around 20 knots with gusts of 45 knots at the time of the passage. Now that is a very strong wind for vessels that are maneuvering in a canal. I once worked on a project where winds of this speed managed to overpower mooring winches, and they broke the steel cables that were holding a vessel tied up against its berth. It's no joke. Winds of this speed do create a danger for ships performing precision maneuvers. Well, that's nice, but there's one problem with this theory. Meteorological regressions suggest that the wind was blowing from south to north at the time of the incident. Now compare that to the chart of the vessel track. Just before they veered into the bank, the wind direction would be somewhere from the stern of the vessel, not the side of the vessel. That has a completely different effect on the ship. It doesn't completely eliminate the wind as a concern. Even a stern wind can interact to create problems for steering, and it can generate some sideways push on the vessel. But all of those scenarios are likely to be a much smaller force than the full-scale force of the wind pushing straight on the side. So too bad, the wind wasn't the answer. At least, I don't think so. Remember that I haven't uncovered any recording of the actual wind direction at the location of the Ever Given, which is very normal. Weather stations don't record data for every minuscule point on the planet for every minute of every second of every day. We rarely need such precise information. Yes, it is safe to say that the wind played a part, but I can't say if that was the smoking gun that started the accident. We would need more information to be certain. Now let's talk about the vessel's speed. The Suez Canal Authority has brought up the issue that the vessel was over its speed limit at the time of the accident. So why were they doing that? Why were they increasing their speed? This has to do with steering. The ship's steering control, its capability, changes depending on its speed. Functionally, that rudder produces a lot more force at higher speeds. The amount of force depends on the speed of the water flowing over the rudder. Faster water speed equals more force. More force equals better control for ship steering. And that relationship between speed and force from the rudder, it goes up by the square of water speed, which is really important. Double the speed over the rudder, and you get 4 times the rudder control. That's a huge improvement. So based on the transcripts and the data recordings, we do know that the ship increased speed, which gave them far more rudder control. It's possible that the wind created challenges to maintain position in the canal, and this was their reaction. They increased speed for better control. That is generally an accepted practice. But did this introduce other problems as well? The other major concern was the bank effect. Yes, the bank effect is a real thing. The short version is that as the ship is traveling along, it's pushing water out of its way. That water flows around the side of the hull and underneath it. Now, if you take that water flow pattern and put it next to, say, the bank of a canal, it starts to interact with that bank in interesting ways. Net effect is that the bow wants to push out away from the bank, and the stern wants to get pulled in towards the bank. That happens just by being close to the bank. But good graphics and a pretty explanation don't make it the truth. I mean, sure, it seems tempting. We see this scary, subtle physics phenomenon capable of generating massive forces. Oh no, the monster is here to eat us! Except, not always. Here's a thought for you. The bank effect occurs with every single ship that passes through the Suez Canal. If this were a killer problem, we should find ships thrown into the bank every day, left and right, lining the sides of the canal. We don't. The magnitude of this effect matters. Does it dominate the ship maneuvering, or is it just a mild inconvenience? Size matters. So to properly answer this, I would probably need 2 to 3 months of detailed numerical simulations. That would be that forensic engineering before we could honestly say yes or no. But you don't want to wait 2 to 3 months. So in the interim, we can use a similar phenomenon to get a sense of the magnitude. Use it as an analogy. I previously did some work predicting passing ship forces. This happens in commercial ports where large freighters pass fairly close to each other. The water flow around these ships both pulls the ships together and then pushes them apart, depending on their alignment. The causes behind that are the same physics that create the bank effect, and we can use this model for a passing ship. So if we're trying to get an idea of whether or not the bank effect mattered for the Ever Given incident, we can take this model of passing ship forces and we can use that scenario as an analog to the bank effect. It's not strictly the same thing, but it tells us whether or not we should be looking into it further. The figure on your screen shows the yaw moment produced by a passing ship scenario that mimics the situation of the Ever Given in the Suez Canal. Now, since this is an analogy and not a strict model, I've hidden any specific data to support definite conclusions. Keep always in mind that this is just an indication, not a conclusion. But this graph does give us a good sense of proportion. If we were to see a yaw moment of around 10 to 20% of the ship forces, that bank effect would be a mild inconvenience. The rudder could correct for that. We're trying to find out if there's something that completely overpowers the rudder. And the graph does suggest that this is possible. The bank effect could vary all the way from something that's relatively minor up to a major threat for vessel safety, something that would easily overpower the rudder. And the exact answer of that depends very much on the ship's speed and the separation from the shore. At the low speed end of just 6 knots, that separation distance was less critical. No matter what position you pick, the yaw moments present relatively little risk. But at higher speeds, these forces increase much faster. And if we think about that in terms of humans running the ship, we can realize that this reduces the margin of error. The ship will never be perfectly on center line of the canal. So we have to ask, well, how far can they deviate to the side before they're in serious trouble? And we find out that at higher speeds, that's a much smaller margin for error. Remember, this is just an analogy. It's not a definite conclusion one way or the other. But it does suggest that bank effects are worth investigating for the Ever Given incident. Hooray! We have the smoking gun! We know what happened! The bank effect is to blame. No, it's not. Probably, maybe not. Pretty graphics do not make something automatically true. Even my pretty graphics. That graph of yaw forces could also look like the figure that you now see on your screen. And the only thing I did was change how I was interpreting the physics underlying it. Ugh, how frustrating. A single little flip and we don't know what the answer is. So what is the answer? Well, we don't know. I don't know. We don't know. That is the answer. With more detailed information, yes, we could conduct simulations, reproduce the exact sequence of events that led to the accident, and find out exactly what happened. But those details are the private information of the ship owner. They're protected by law. We may have suspicions, but lacking any further details, the answer is always going to be, I don't know. I don't know. That's important, especially when it's being said by people like me that have the platform of YouTube to publish our thoughts on. When accidents like this happen, public opinion matters. It's natural that we want answers. We want them so badly that we're ready to take any suspicion as a final conclusion. That creates real economic risk for everyone involved. There's a real fear for the owners, the crew, the pilots, and the Suez Canal Authority. Everybody involved has reason to be afraid of damage from public opinion. And when people become afraid, facts become scarce. We become more worried about blame than about understanding the truth. So who do we blame for the Ever Given accident? That's what everybody's really asking, right? I don't know. Not a satisfying answer. But I can accept that in favor of a more important question. Since the time of the Ever Given incident, approximately 18,900 ships have already passed through the Suez Canal, including the Ever Given itself. She's back in service after her repairs. All of these passages happened without major incident. So what was different? Why no incidents? What can we change to avoid another Ever Given in the future? There's some food for thought. Thanks very much. I am Nick, the Naval Architect. Thanks for watching. I hope you liked it. What is ship design to you? Because my job as a professional engineer is to take your understanding of ship design, that general goal, and turn it into technical specifications to make it a reality. So check out the website and let's see how I can take your dreams and make them possible. Thanks very much.